So, here we're starting on the min and max. So, as you can see here, in this statement, we can find the min of this array, and then here we print it out, and then over here we are finding the max. But, what if there's a situation where I need to find the max of an array 2 times? Well, then in that case, I would have to write all of this twice. Same happens if I need to do that with the min. And that's really not convenient, especially when you need to repeat more larger lines of code. The way that this gets solved is through functions or methods. So let's look at how to do those. So let's create a new program so that we don't disturb this one. New Java class. We'll call it min max function. Right. So here, let's type in the main function. Right? So we're going to type in that boilerplate code, and then let's make an array. So let's make 2 arrays. Arrays of different things. So we can have int, an array of ints, and let's call it array 1. So let's make this equal to 1, 7, 3, -2, 12. Remember, we have to have that semicolon at the end. So, we have that. Now, let's do a list of doubles and compare that. We'll call this array 2. And in this, we'll have 2.5, 3.7, -1.0, 7.1. Right? So array 1 has 5 elements in it, and array 2 has 4 elements in it. So let's say we want to calculate the min and max of both of these. Well, we don't want to have to write this 2 times. So let's start a function. As you can see here, I'm actually writing this outside of the main function. You have to do this because the compiler actually doesn't start by reading the function, it starts in the main, right? So whenever you call the function, it will try to find it over here, and if it is, then it will do the function. So, public, static, and we have a couple of choices. We can do int, right? Or void, or boolean, or double, any of these. This is what it will return. So, if depending on what you want to return, meaning what the min and max is going to be, then this would be different. So let's talk about returning. In the function, after you calculate the min and max, you can do multiple things. Either you can straight out print it in the function, or you can make some sort of variable, let's say int I, and make it equal to the function. So here you would have to call the function. How do you do this? Well, you type in the name, and then you type in brackets. So let's continue working on our function. Now, as you can see, the int and the double, they are different types. So you can't return, in one function, you cannot take in both of them, right? So, and we'll see that later. So now we have to have the name. So let's do min first. So public static int min. As you can see here, it is the same color as array1 and array2. This basically means that they haven't been used yet. So here we have the parameters. In the parameter, this is the input to the function, right? What you are giving to the function. So here we are returning an int, so we will take in an int, an array of ints. So let's just call this A, right? So our array is just called A, right? So now as we can see, to do int and double, you'll need different functions for that, right? So for the double over here, instead of having an int, you would have double and double, right? So we will do those minor modifications after we finish the int ones, right? So then here we have to have the brackets to see what is actually inside. So then, since we already have the min here, let's just copy it in. Except we have to do some little modifications. First, there's no array, right? Even if this was changed to array, it wouldn't really matter because the function, you see, it doesn't know or care that it's there. Whatever is given to it, it gets and is stored in A. So let's say if inside of here for the parameters you give array 1, well, it's still going to be called A, right? But A isn't accessible to any other thing. So in the main, if you try to do A equal to an empty list, then it won't work because over here, this is outside of the scope of A, which in this case is only the min function. So now that we've replaced A with everything, we have to return the min. So here we go outside of the for loop, and all we have to write is return. As you can see there was a little reminder. It's like, do you want to type this? I just clicked enter and it filled it in for me. Now all I have to do is return min. So let me show you how this would look like. If we wanted to print this out, we would go system dot out system dot out dot println, right? And then here we would just call the function min, and inside of the parameters here we would give the array. So since this is the one that returns int, we would just do array1, which is the one that's int, right? And then that's how it works. So let's say we had an array3 and that was an int. Then instead of having to write it all over again, we could just have one more line of this, right? System.out.println, right? And then we could just have array3. Obviously that won't work because we don't have an array3. So this same concept would work with max, just with the little tweaks. So, if you have some functions, then they can't have the exact same name and parameters. So let's say we made another function over here. Right? As you can see, there's this little red thing. And it's saying that basically this is kind of so first of all, this doesn't have a return, so let's just do return an int, which is 4. We can do that, right? As you can see, now we have a new problem. See, it's already defined. It's literally the exact same definition, and we can't do that. But let's say instead we just have a normal int. This will work because there's still some way to distinguish the two functions. So this way we can just simply take the code from over here, right? And simply change a couple things. So change that to double, change this to double, because remember we want to take in double. Over here, this has to be double. This has to be double. And that's about it. Now what we can do is over here, we can have this same thing. And then, instead of calling array1, we would call array2. So let's run this code. So, here you can also do this with the max. All you have to do is you just want to change the name to max so that you know it's max. You might want to change the variable name so that you know that it is max. Alright, so let's look at the results. For the int, right, the one with no decimal, we see -2, which is the min. Then for the next one, we see -1.0, and that is what's outputting. So this is working perfectly fine. So if you wanted to have the max here, you would just have to make some little minor changes, right? You'd have to change the name so that you can distinguish it. You might want to change some of the names of the variables so it's less confusing. And then you just call that. So functions are very, very useful when you're using a piece of code a lot and you just don't want to repeat it. Alright, so now let's talk about recursion. Recursion is just a different way to do things, right? So, as you can see here, we're going to be calculating the factorial. What factorial is let's say you want the factorial of 3. Then the factorial of 3 is 3 times 2 times 1. The factorial of 5 is 5 times 4 times 3 times 2 times 1. So, obviously, you can calculate this with iteration, meaning with loop, right? As you can see here. But you can also calculate it using recursion. As you can see here, recursion is a little more simple. And as you can see, it is actually calling the function from inside of the function. So what this is doing is it's making factorial 1. It's starting out I as 1 because you don't want to multiply 0, then all of your factorial going to 0. And you make sure that I is less than or equal to your factorial number because you also want to multiply the number of the factorial. For example, in the factorial of 5, you're still multiplying 5. Then we have I plus plus because we want to keep on progressing by 1. Then we're doing factorial equal to factorial I and F in every single iteration. After the loop, we're just returning factorial. So now let's take a look at recursion. We're checking if the factorial number is 1. Factorial number is whatever number factorial you want. For example, 5 could be a factorial number because we want factorial. So if the factorial is less than or equal to 1, you're just going to return 1, right? But then, if that if statement is true, it's going to return, and the function's over. Once you return, the function's end. It doesn't do anything else, right? So this would be the point where it kind of stops. But if it doesn't go through that, it goes to this root. So it goes to factorial num times and now it's calling recursive fact again, right? So whatever the recursive fact returns is going to be multiplied by factorial num. And in this case, you're doing factorial num minus 1, right? Because that's what you do. But once you get to that, let's take the example of 4, right? So it's 4 times recursive fact 4 minus 1, which is 3. So let's go back into it. 3 is not less than equal to 1, so it will return 3 times 3 minus 1, which is 2. Then, when it goes back into that, 2 is not less than or equal to 1. So 2 times 2 minus 1 is 1. So when it goes into that, 1 is less than equal to 1. So it's just going to return 1. Then what happens is we go back to here where factorial num is 2. So it's going to be 2, right, factorial num, times 1, because it's returned 1, right? Then, when it was 3, it would be 3 times the answer of when factorial num was 2, right? And 2 times 1 is 2. So now 3 times 2 is 6, right? And then since that returns 6, we go back to when factorial num is 4, and then this, when it returns, right, it returned 6. So it's going to be 4 times 6, which is 24, which is in fact right. So recursion is whenever a function is calling itself, like this. So let's run it. As you can see here, they deliver the exact same answer. They are just implemented in different ways. So recursion can be used to solve problems a little bit differently. But note that recursion takes a different mindset to solve, right? You have to think about recursion and how to call back, right? And what you're going to do for it. let's talk about OOP, or Object-Oriented Programming. This is a pretty big and complex topic, and I will discuss the basic concepts here. Object-Oriented Programming is very useful, and you need to know at least the basics for object-oriented programming languages like Java, which have classes. You've seen this, and in every program you can see that the whole program is engulfed in a class. So a class is a concept to help model real-world objects. For example, a car would have a bunch of different properties: color, model, manufacturer, right? All those different things, which can be represented as variables. And it can do a few things, such as moving forward, turning, moving backward, and those can be represented as functions. So a class is a blueprint for the different variables and functions. Now we have objects. An object is an instance of the class, or the actual thing. For example, the class in the car example would be the blueprint for the car, right? The thing that you're basing it off of. And the object is the actual thing. So example, you have an Audi, right? Manufacturer, Audi. Model would be something. The color would be something. But it would have it would be able to do everything that the blueprint says, right? And everything would be built off of the blueprint. Same if you would model a Porsche or a Toyota. This same thing you can do with vegetables. You have a vegetable, they have different vitamins, right? And all those stuff. And then carrots, celery, lettuce are just different kinds of vegetables. So now, let's talk about inheritance. Here, as you can see, we're continuing with the car example. You have a vehicle, right? It has its variables and methods. A truck is a kind of vehicle. A plane is a kind of vehicle. But we also have a car. With inheritance, you can basically port over all of the methods, variables from vehicles into cars, except car can be a little more specialized. So car has all of the same variables, right? It has all of the same methods, except it's a little more specialized, right? Cars can do certain things that other vehicles may not be able to. So vehicle is derived from a class. For example, in a vehicle, you might be able to move forward, move backward, right, turn left to turn right, and really, and then you would have model, all that sort of stuff. But with cars, there would be a lot of different things that you can do. Same with motorcycles. They're built off of the vehicle, right? But they still have some stuff that the vehicle doesn't. So now let's look at how to define a class. So, I have done something here. As you can see, it looks a little bit cluttered, but I'm just going to draw a line to make it easier. So, this class is called Class 1, and in the main of the Class 1, the main doesn't relate to anything inside of the Class 1. Main is just running stuff, right? But inside of here, as you can see, we have different variables, right? X and SX. Then we have some methods, right? So, as you can see here, we are creating two different objects for the class. So, in Java, the class becomes a type. So, as you can see, class 1 is now a type, and you're giving a name equal to new class 1, and then brackets, semicolon. Then here, we are just doing certain things. So you might ask, why aren't we just going x equal to this? First of all, as you can see here, there's a little difference between s and sx. As you see, there is static in s, x. But in x, there is none of that. So, this does a couple of different things. But first, let's look at the private. What the private does is that anyone outside of the class, right, that's using the class, for example, on the main, we're using the class, can't access x and sx. Only within the class can those be accessed. So instead of that, we've made some functions. You would want to do this because it's just easier to use a function. So now, let's look at static. As you can see, the functions that are operating on sx are operating directly on class 1. This is because it's static, meaning that sx is the same throughout all different instances of class 1. So you don't change it within my class, right? But in here, you'll see that you have to change x for each of these. Basically, in these, the different x's belong to the different classes. For example, in the car example earlier, let's say x was color. All of the different colors would be different, right? So they wouldn't be static. But what would be static in a car? Well, this would be the number of wheels for the car, because all cars have the same amount of wheels. So those are the basics of object-oriented programming. And there is much more to it, but that gets very complicated. So this is all you need to know for now. Now let's do some practice with functions. You'll have to write a couple functions here. First, a function which neither has input nor has output. So you really can do whatever you want with this function, right? You can have it be called print high, and it could just print high, and that's all the function could do. Next, we have a function that has one argument. You can call this 1arg, just to differentiate. It has one input and returns nothing. You can call this print, right? Or print int, or print string. You have an input, and then you just print that out. Write a function which returns an integer. You write a function, right? And it just returns an integer. You can return 1, 2, 1 plus 2, 1 times 2, whatever you want. Write max in a function. We did min earlier, you just need to make some little tweaks. Feel free to look back at that video. Then implement a function named greater, which takes in two integers as inputs and returns the greater of the two. Pause here, do these exercises, and I will give you the answer after a few seconds. For the first one, as you can see here, I called it one arg, no arg, no return, and all it's doing is it's printing hello world. Now, one arg, as you can see here, is in one line. Yes, you can do this. In fact, you can write a whole Java program just in one line. This is just so that since the function isn't very big, you can just put it in one line and keep it in one small package. And as you can see, it just takes in a string and it prints it out. Write a function which returns an integer. This is just called ret. It has no arguments, and it returns 10 plus 20, which is 30. So you just get 30. As you can see here, max is just the max thrown inside of a function, and it's inputting an array of ints. Now, in the function named greater, it's taking an int I and int j. This is a convention. Just like you either use I and j, or a and b, or x and y. Those are the general norms. So then you're checking which one's greater, and you return the greater of the two. To practice recursion, I will be telling you about Fibonacci. If you already know about this, then feel free to skip ahead, but I think it's good to have a little refresher. You always start with 0 and 1, so 0 and 1, and you add the last two numbers to get the next number. So what is 0 plus 1? 1. What is 1 plus 1? 2. What is 1 plus 2? 3. What is 2 plus 3? 5. 3 plus 5? 8. 5 plus 8? 13. And this keeps on going on. So, if you want to find out the nth Fibonacci number, this is how it will go. 0 is the 0th. 1. This one is the first. This other one is the second. This is the third, this is the fourth, and this is the fifth, and it goes on. So, here is the prompt. You have to write a recursive function to calculate the nth Fibonacci number. Remember to call this function fibr. Then you have to write a function to calculate the nth Fibonacci number iteratively. Call this fibi. As you can see here, fibr and fibi are red. This is because they are not made. That is your job. Pause it here, and after a couple seconds, I will give you the answer. Here is the answer. As you can see, the recursive function is very, very, very minimal, while the iterative is much more complicated. As you can see here, I am using long to return, because if you want to do higher Fibonacci numbers, then they can get pretty long. Note that when I run this, even though I'm calculating the Fibonacci the 50th Fibonacci number in iterative versus the 5th Fibonacci number in recursive, the recursion may be slower because the recursion is very, very slow when you are doing Fibonacci. If you were to do fibr 50, this may take forever on your computer, depending what you have. In this case, fib r of 5 shouldn't be too bad. If you want to know how and why the Fibonacci with recursion takes so long, then you can watch my other video. I will link it down in the description and you'll be able to find it there.